Hello. So, in today's session, we are going to discuss when you are given a question which is asking you about how many solutions does an equation have. Okay. It is not an algebraic one. Okay. Because when it's algebraic, it's relatively easier to work with. May have a trigonometric function, you may have exponential, you may have a logarithmic function, etc., etc. Okay. Now, as soon as I see the question, the first thing I know is that I'm going to plot it. Why do I know this? Is that they are saying how many solutions. They are not asking me for the exact solution, exact answer when this is satisfied. Just how many times is this equation satisfied, okay? So that's my hint that I have to plot it, think about what it would look like and try to solve it. Okay, so let's get started. First of all, let's look at what we have. We have cos of x, and I know cos of x is only between minus 1 to 1, okay? It cannot have any value which exceeds 1 or is less than minus 1, okay? So that means this is only going to be satisfied when x is also between minus 1 to 1, okay? So step 1, we restricted domain, okay? We restricted domain by saying that although it's basically implying that x is over all real values, but it's only possible for our case when it is minus 1 to 1. Okay, good. Now that we have that, now let's see. Okay, the thing is, now you have step 2, further restriction, if we can do that. Okay, restriction. And that is that, as I see, cos of x when x is between minus 1 to 1 is a positive function. Okay, and that tells me that if I'm writing that, if I'm giving me this is positive, this also has to be positive. So my further restricted domain is just minus 1 to 1. Instead of minus 1 to 1, it is 0 to 1. Okay, all right, I'm dealing with this now. Okay, now let's see. I know if I have any solution, it may happen that there is no solution. But if I have it, it is only between 0 and 1, okay? So I check what happens to the function. Let's write f of x, which is cos of x minus x. I have essentially taken left-hand side equals to right-hand side to left-hand side minus right-hand side, okay? What happens to this on the extreme points, which is what is f of 0? F of 0 is cos of 0 minus 1, right? And what is that? Sorry, it's a 0. So what is that? That's a positive number because cos of 0 is just 1. It's greater than 0. Okay. What about f of 1? F of 1 is cos of 1 minus 1. I know this is 0. Why? Because cos of 1 is less than cos of 0. 1 radian is going to be about something between, I think, less than 90 degrees. So it's approaching 0. Okay. So it is negative. So first thing I know is that this function is going from something positive to something negative. I don't know what that number is here. I don't care what exactly f of 1 is, but it's a negative number, some minus a0, let's say. Okay, and that means if I try to plot it, it must intersect at least once. At least once. Pay attention to the at least here. Okay, because it doesn't mean there is only once that it is intersecting the x-axis, right? It may happen more than once, but at least once. Okay, so now we know that we have between 0 to 1, there exists at least one solution. Okay, now we want to know, is it just one or more than one? Okay, at this point, we are now going to deal with the calculus. Once we have all these things, we try to do some calculus. So what is my f of x? F of x is cos of x minus x, okay? Now I'm trying to see, is my function increasing, decreasing? Does it have concavity or convexity? What does it look like, right? So if I have this, I take the first derivative, okay? My first derivative is just minus of sine x minus 1 remaining in the interval that we are, okay? and sine 0 to 1, I know the sine is a positive number, gets multiplied by something negative, okay, and then negative, so it is a negative number on this domain, okay. And that tells me that my f prime x, the first derivative, is always negative on this interval. That means my function is decreasing. It's only decreasing. It cannot be increasing and then decreasing or something like that. No, it's decreasing. That means if I go further, it's just going, like going down here. It cannot have such a structure like this. Nope, that's not possible, okay? It can only go down, okay? And that tells me if it is strictly decreasing, so there's only one solution. It's only one solution. Now, I would like to say that some of the students may think like, oh, it was a pretty trivial case, cos of x equals to x, I can directly plot it instead of going through all this mess, okay? Which is true. However, the question, just with a slight tweak, it can become non-trivial and it can become tricky and difficult to solve, okay? And that's why I picked up an easy problem that you can do by just plotting left-hand side independently and the right-hand side independently, and then try to see, do you get any solution to that or not? But I used a rather non-trivial way to solve it, so that when we have the other problems which are actually non-trivial to work with, can be a bit tricky, confusing, we can apply the same method, same approach to solve those problems, okay? Now, I want to add a few things where the students can fail. The first thing is that the domain, okay? You have to be very careful with the domain. Here, in this particular case, they just say that x is over all real numbers, okay? They may actually give you a domain. They may say x lies on 0 to 1, minus 1 to 1, or something else, okay? In that case, you should be careful and directly go with that domain, okay? Don't kind of skip over that part, okay? The second thing is that you must always pay attention if the function is increasing or decreasing, okay? That tells us whether this f of x is, how many times it's going to intersect the x-axis, okay? The third thing is to check for the endpoints. As soon as I had my domain, and it's great if the problem is already giving you the domain, the first thing I do is I check what is the value of the function on the endpoints, okay? Because that tells me, already gives me an idea if I'm getting at least one solution or none, or what is exactly happening. And then I try to differentiate and I see what the graph is on that particular domain, okay? So that's what it is for this problem. As an exercise, I will leave a problem to the students. That is, let's consider an exercise. This is for students to do in their own time. X. Try to see how many solutions does this equation have. In the next video, we will look at the same question. We will be doing cos of x equals to x. However, we will make it a bit non-trivial, and we will see it how exactly do we do that in the next class. Okay, thank you.